Have you ever wondered how your usual life would change if the day became shorter? Do you think that's merely a fantasy? Well, back in 2007, scientists suggested that the Earth's speed of rotation was increasing due to global warming. And this could lead to serious natural disasters and shocks to the human body, because our whole life is imprisoned within the 24-hour day. So could humanity survive in a world of accelerated hours? What threats would we face? Due to global warming, the Earth could begin rotating around its axis faster. Such a shocking forecast was made by scientists from the Max Planck Institute for Meteorology in 2007. According to their calculations, over the next 200 years, the length of the day could decrease by 0.12 milliseconds. You're unlikely to notice these changes on your watch, but if the scientists' forecast is confirmed, the consequences for humanity will be simply terrible. Our planet rotates on its axis, making one complete revolution in 23 hours, 56 minutes, and 4.09 seconds. This period of time is called a sidereal day. It's the duration that scientists have come up with observing the speed of rotation of our planet. Ordinary people are used to calculating time by calendar days, consisting of exactly 24 hours, or 86,400 seconds. But has a day on Earth always been this exact length? Turns out, no. According to experts, 1.4 billion years ago, the Earth made a revolution around its axis in about 18 hours and 40 minutes. If this happened today, the consequences would be disastrous. First of all, the very form of our planet would change. Due to the rotation of the planet around its axis, a centrifugal force arises, acting on the equator region more strongly than on the poles. That's why the Earth today has a slightly flattened shape, as if someone is squeezing an air-filled ball from above and below. This phenomenon is called equatorial bulge, and by today's standards, it's not very noticeable to a simple observer. The difference between the equatorial and polar radii is only about 21 kilometers or 13 miles. But if the speed of the Earth's revolution increased several times, our planet could stretch really wide, resulting in an increase in the length of the equator and a decrease in the distance between the North and South poles. As a result, our planet would look like an ellipsoid, similar to the way that Haumea, a dwarf planet located beyond the orbit of Neptune, looks today. The next effect of rotation acceleration is a decrease in gravity. All objects located on the Earth's surface are affected by gravity directly to the center of the planet, and centrifugal force directed from its center. And if the same gravitational force at the pole and the equator is approximately the same, then the centrifugal force at low latitudes is stronger than at high. Due to this, there's a difference between gravity at the equator and in the polar regions. But if we assume that the rotation of our planet noticeably accelerates, this could cause a real catastrophe. First, due to an increase in the difference in attraction at the poles and equator, the waters of the world ocean would rush to the tropics. The rise in the water level could be so rapid that entire islands and states would be hidden underwater. In addition, a decrease in gravity at low latitudes would contribute to humidification of the atmosphere. Thick clouds, frequent fog, and heavy rains. This would become regular weather in popular tropical resorts. As rotation accelerates, more and more atoms and molecules would leave the atmosphere and escape into outer space. This phenomenon is called atmospheric escape. It's because of such dissipation that Mars, the Moon, and Mercury have virtually no air shell above their surfaces. I don't think you'd be pleased to live in a vacuum. Well, If you spun our planet about 17 times faster, the speed of objects on the Earth's surface would reach the second cosmic velocity, the minimum necessary to overcome gravity, and you and I would simply be carried away into outer space. But we don't need to imagine this fantasy version of such strong acceleration, because even a small change in the length of the day could cause weather disasters. Under the influence of the Earth's rotation, air and water masses near the equator and poles move at different speeds. This effect occurs due to inertial force. Due to this force, there's a transfer of air masses in tropical and temperate latitudes, and warm and cold ocean currents also arise. If the effect of inertia increased, cyclones would become more powerful and destructive. In addition, due to the decrease in the length of the day and night, the daily fluctuation in air and water temperature would be less. According to some reports, the climate would become generally cooler because of this. Another source of problems for humanity may be due to changes in the underground ocean of our planet. As you know, deep below the Earth's surface is the Earth's outer core, an ocean of molten metals, the thickness of which can reach 2,400 kilometers, or about 1,500 miles. It's the movement of these metals that creates the Earth's magnetic field, which not only protects us from deadly cosmic radiation, but also allows us to determine cardinal directions using a compass. An increase in the angular velocity and the radius of the Earth could lead to a geomagnetic reversal. During the inversion, the magnetic poles of our planet would change places, and the compass needle would begin pointing south, not north. Imagine how complicated the life of travelers would be if all navigation systems began showing opposite directions. The acceleration of the Earth's rotation could cause real chaos in the field of space technology. As of December 2019, 562 satellites are in geostationary orbit. This orbit is calculated taking into account the existing rotation speed of our planet. The same side of the Earth always faces a satellite in this orbit. It's because of this that dozens of navigation and information systems work today. Upon acceleration of the Earth, the satellites would be below the required altitude, and many of them may not have enough fuel to change their location. Finally, a change in the length of the day could cause serious health problems. Have you ever moved to another time zone? If yes, then you know how difficult it is to get used to adjusting to the clock. Our body has adapted to falling asleep and waking up at about the same time, and switching to a new time zone can be very painful. This condition is known in medicine as jet lag. As a result, after changing time zones, many people experience fatigue, sleep disturbances, and decreased attention and memory. Now, imagine that the day becomes 1 to 2 hours shorter, and your body has to change the daily settings of its biorhythm. Moreover, our usual life is built around 24-hour days. The length of the working day, company shift schedules, all this would have to be changed. As for sleep and rest, Earthlings would have even less time. In general, there are few positives in accelerating the Earth's rotation, but don't get scared too quickly. Fluctuations in the length of the day within a few milliseconds occur constantly. These changes are very small and have almost no effect on the previously mentioned physical processes. In addition, at the moment, the duration of Earth's days are even increasing by about 1.7 milliseconds per 100 years. This is mainly due to the tidal force of the Moon. The mass of our natural satellite is about 1.2% the mass of the Earth. This is quite a lot by the standards of the solar system. The tide in the ocean waters caused by the Moon, as it were, run onto the shores of the continents, moving in the opposite direction from the direction of the Earth's rotation. Thus, the tides slightly slow the rotation speed and help make the day longer. So, most scientists believe that our planet would rather stop before it sped up to a speed that threatens humanity. However, who knows? Maybe this would lead to even worse consequences. In your opinion, how would a change in the Earth's rotation speed affect humanity millions of years from now? Write your prediction in the comments of this video. Until next time.